worries. Hello, everybody. Welcome to Office Hours. Hopefully everyone can hear me and see me. I'm actually just going to take a second to click on the link to make sure that I am in fact broadcasting. So give me just 1 second. Okay, I am. Awesome. And let me go back there. Okay, so today we're going to talk about InfluxDB and using it with PySpark. So what are we going to learn today? We're going to learn what is PySpark, and specifically how we can use Aeroflot SQL to query InfluxDB, and then use PySpark to create a PySpark data frame, and then manipulate the PySpark data frame with SQL, which is one of the advantages of using PySpark, so that you don't have to use Python and you can, or pandas, and you can use SQL or pandas interchangeably to manipulate the data frame, kind of whatever your preference is, and then convert the PySpark data frame to a pandas data frame so we can actually visualize the data with matplotlib and Seaborn. And then we'll also convert the data frame to a Parquet file, because a lot of machine learning tools allow you to import Parquet files, and they're just a really cheap, compressed, durable file format. So we can use them to like offer us more interoperability with other tools. And then last but not least, we will perform some multiple linear regression with PySpark's ML module. And just I wanted to give a heads up, just kind of like a quick warning, that will be a very kind of um, meaningless example, so to speak, just because our data set that we're using today isn't really like ideal for that. But it's just kind of to introduce you to these tools so that you can know of their existence and how kind of in theory to use them if you were to use them for yourself. And then last but not least, I'll share like how we can run this code yourself, and also like additional resources just to learn about how to use InfluxDB and PySpark and all the other things. Okay, so first and foremost, we'll be talking about what actually is PySpark. Hold on, I just lost everything. Okay, so PySpark is essentially used to perform big distributed computation for purposing really big data. So you can do parallel processing across a cluster of computers with PySpark, and it allows, specifically PySpark allows Python developers to interface with Spark, and take advantage of that distributing computing capability. Um, so it's essentially just an interface for Spark, and um, then the kind of components of the Python machine learning libraries include the Spark SQL module, the machine lib module, and the graph XL module. And the latter is, for processing data, to work with graph structured data. The ML machine learning library, Spark modules for machine learning, and it provides a wide range of machine learning capabilities, but it's primarily focused around processing your data and clustering your data and classifying your data. So that's not typically like what you want to do when you have time series data. You're usually only interested in forecasting. But there is some like linear regression available too. So, and there's a lot of tools within it for preparing your data. So that could be useful for incorporating other time series libraries on top of it specifically. But I didn't see like a bunch of things that I would be using off the bat for time series data. Of course, everyone's use case is different, but I think there's like better choices like Facebook Profit or Meta Facebook Profit, or CATS, for example, if you're interested in forecasting, or the Anomaly Detection Toolkit if you're interested in that as well. So yeah, essentially it's just a powerful tool for processing large-scale data sets using Python and Spark. So what makes PySpark so performant? Well, it gives you access to distributed computing. It also has a lot of in-memory processing, which means that the data is kept in memory rather than being written to disk after every operation. It also utilizes lazy evaluation, which means that it'll delay the execution of any computations until they're absolutely necessary. So it's just really optimized to execute operations and avoid unnecessary computations. And then it uses RDDs, which is our resilient distributed data sets, which are collections of data that can be processed in parallel. And then it also uses really efficient data structures, like data frames, for example, which are optimized for distributed processing. And specifically, you can use PySpark data frames, which I don't actually know how under the hood they differ from Pandas data frames, but I'm assuming it has to do with the way that they're structured. So now that we've talked about that, I want to talk a little bit about the difference between Flight SQL and PySpark because we will be using Flight SQL and PySpark together. So Flight SQL is the framework that we'll be using to query our data from InfluxDB with Arrow, um, and it just leverages Arrow to transmit data between a client and a server, and utilizing the SQL language, while PySpark is the framework for processing and um, analyzing that data. So that's just kind of some background there before we get into it. So the first thing that we're going to talk about is how we can query InfluxDB Cloud and create a data frame with PySpark, PySpark data frame. So we first import our dependencies. We'll import the Flight SQL library as a Flight SQL client, and also PySpark SQL as our Spark session. We'll also try to suppress some errors. That line after the imports will basically just uh, suppress any logging that is trying to be generated by um, this logging library for Java. Um, so it's usually safe to ignore that, and that's why I have that there, but you don't have to include that yourself. Then you gather your authentication credentials from InfluxDB, including your token, your URL, and your org if you wish later to use the Flight SQL client to write data back to InfluxDB. I'm not going to show that here, but if you go to the Influx community repo on GitHub, which is literally called Influx community, one word, then you can find examples of that there. And then we're going to create our query. And next we instantiate the Flight SQL client by providing the URL, the token, and the database. Then we actually execute our query, and that for right now is select all of our data from a table or measurement called air sensors, and we'll just limit the first results to 10, just to make this simple so we can see all of our data. Like I said, all these examples are kind of dummy examples to just familiarize yourself with the tool and how to use them, but they're not like really real world because we wouldn't care to use PySpark for a data set that small. Obviously, we'd want to use it for something really substantial. And then we create a client reader to consume the result, and then we can convert that to a PyArrow table. And next we connect to PySpark to create and convert it to a PySpark data frame. We use the master sets the Spark master URL to connect to, such as local, for example, if we're running it locally. And the local star selects like how many cores we want to use, or in this case, we're using all of them. Or you could use like Spark // master 7077 if you wanted to run Spark on a standalone cluster. And then we say data frame show or df show to view our data frame. So this is what our data set looks like. It's gathering carbon monoxide, humidity, temperature values from a variety of different sensors for a particular time. Since we only selected the first 10 values, we're only seeing data from one sensor, sensor TML 0, 100. But there are, I think, 8 or 9 sensors total in the entire data set. So if we queried for more data, we would see some more sensors. And next, we'll learn about how we can use SQL to work with our PySpark data frame. So data frames and Spark SQL share the same execution engine. So you can use pandas or SQL interchangeably and seamlessly. And so that's one of the advantages to using and creating PySpark data frames, is just that flexibility and access to other functions and whatever you're familiar with using when you are analyzing and manipulating your data frames. So for example, we can register the data frame and execute a SQL query this easily. So we replicate the view and we name it, and then we use spark.sql, and we give it our SQL function. In this case, we're going to say like select the count. Since we limited 10, we should expect a count of 10, and that's what we get. And we can use the show function to actually return a Spark data frame with that result. So yeah, you could use any SQL that you wanted to, and then from there you could also, convert that back into a pandas data frame if you wanted to, which is actually what we'll do in a second, because there aren't actually ways to visualize the data with PySpark. You have to convert stuff back into a pandas data frame in order to use libraries that you would use to plot data frames, pandas data frames. So, but before we talk about that, I want to also teach you how to convert a data frame into a Parquet file so that you have access to other analytics and visualization tools. So basically what we're going to do is really simple. You would take your PySpark data frame and convert it to a Parquet file with the toParquet function, or you can read a Parquet file and then save it as a data frame if you wanted to as well. And you just have to make sure, and I forgot to include that in this screenshot, where you first convert it to a pandas data frame as well. So in order to then convert it to a Parquet file, but that's just one simple line. So what are Parquet files? They're basically compressed columnar data formats, and they take very little disk space. So they're really fast to scan because they're column oriented, especially with time series data, where a lot of the values in a single column are going to be the same. That just enables really fast compression, and the way that there's just a lot of metadata associated with the Parquet file as well that enables really fast scans of it. So uh, basically, Parquet files are also 16 times cheaper than CSV files. So that's another reason why to use them. But another huge reason to use them is that if you do convert them to Parquet files, then you can upload them into a bunch of other tools that support Parquet, things like Tableau, Power BI, Athena, Snowflakes, Databricks, and obviously Spark. And also, if you look at the Influx community repo, there is another example of how to convert a Parquet file to a hyperfile specifically, which is what you need to import Parquet to Tableau desktop. So if that's what you're running and that's what you're using, take a look at that. It's pretty useful. And last but not least, we'll talk about, well, first we'll talk about this and then we'll talk about multiple linear regression, but let's convert a PySpark data frame back to a pandas data frame and then plot the data. So first we'll import matplotlib as plot and seaborn as SNS. And then to convert the pandas data frame to the PySpark data frame to a pandas data frame, we just use the toPandas function. So that's what we'd use to before we use the toParquet. And then this is some code to basically generate our plot. It's what I like about this code snippet, if you end up looking at this notebook, this Jupyter notebook in the repository, is that it'll plot multiple sensors, multiple temperature values for each sensor on the same plot. Since we only limited our results to one sensor, the result we get only shows one line graph, but the same code would be used to plot multiple line graphs simultaneously, and it's formatted pretty, which is what like some of this functionality and code does. So we don't really need to go into that because this isn't meant to be like a Seaborn tutorial, but this is the ending result. And if we had queried for more data, we would see multiple sensors there as well, which is nice. Okay, and then last but not least, I'll show an example of how to use multiple linear regression with PySpark. This is a really poor example of this data set, because if you're going to use multiple linear regression, normally, for something like time series especially, um, first of all, you'd wanna make sure that your time series data is actually independent so that you don't have correlation in your time series data. So something like, stock prices would be a much better example. Temperature, especially of a plant, not really a good idea if you're taking the temperature over multiple days because there's gonna be correlation or seasonality in that data. Um, so instead, you'd wanna do something like, predicting the price of something, and, you'd probably wanna have, like, maybe one independent variable, um, and then you'd have a bunch of other, categorical, um, features in your data set, like, I don't know, sentiment analysis or something like that that you would include, to provide context. If we did do this and we kept to the kind of monitoring our plant example, an independent variable or an independent feature would be something like soil moisture or temperature. And then like type of fertilizer might be categorical instead if you're trying to optimize the growth. So that would be a much better example because right now the only categorical thing we have is a sensor ID in this data set. And now, if we were evaluating the efficacy of different sensors and they were all monitoring the same plant, then that would actually make sense. But since we're monitoring different environments with different sensors, like I said, this is a poor example. But the emphasis here is not on doing something that really has a lot of meaning because this data set is so small anyways, so we wouldn't use PySpark. The example is really just to try to understand how we would use it. So essentially, we're going to use the PySpark.ml module, and that's PySpark's main library for machine learning. And it provides tools for a lot of different things, but primarily for data preparation. It includes a wide variety of algorithms, but primarily for things like decision trees, random forest, gradient boosted trees, clustering, and other classification algorithms. It also allows you to set up pipelines and perform model selection and evaluation. But so here, basically, what we're going to do is use this vector assembler first. We print the schema just to understand what our data looks like, but we already know what that looks like. Then we use our vector assembler to create a single vector column from the list of input columns. And then we select our input and output columns, and in this case, we're going to try and predict our temperature. Then we split our data into train and test so we can compare our prediction against the remainder of our data that we are testing. So we're going to do, 75, 20, 25 split where we train on 75% of the values and test on the remaining 25%. So that's only a couple points, a few points. So we have 10 points total. And then we fit the model with linear regression. Then we train our training data, and then we predict on our test data, and we show our results. And so we can see we have only 3 points as a part of our results because we only started with 10. And we can see our temperature values and our prediction values. And we can see that they are very closely aligned, probably because the model overfitted in this instance. But still, verification that it is in fact working um, from a execution standpoint, and that is in theory how we would take advantage of this. So last but not least, I wanted to share some learning resources. Primarily, that linear regression example really comes from this blog that is present in the first QR code. And then if you want to try this Jupyter Notebook out for yourself, I recommend going to the following GitHub repo, and you can go ahead and give that example a whirl for yourself as well. Some other learning resources, I encourage you to join the InfluxDB University, where you can take a bunch of different classes on all things Influx data, whether that's about InfluxDB or Telegraph, and you earn virtual badges with it, and you can display those on your LinkedIn, so that's kind of fun as well. Yeah, so you get a cool badge. And some other resources to get started with InfluxDB Cloud and the free trial, you can go there. Please ask any questions that you have about this presentation or anything in the forums. Also, check out the Slack, where it's very active. I mentioned Influx Community. That's where you can find the link to the repo that had all the code discussed here, but also examples for how to use Flight SQL, how to use Tableau, and how to use other forecasting libraries. The docs are always super useful. And then blogs and InfluxDB University is there as well. So that's all I have for today. If anyone has any questions, I encourage you to ask. Otherwise, I'll wait around 3 minutes or so and couple minutes and give you time to ask any questions. And if you don't have any questions, then I'll see you in the next office hours, which will be next Wednesday. Thanks all.
Yeah, thank you so much, Anais, for that presentation. And yeah, we'll stick on for maybe like a minute or so. Because also feel free, guys, to anybody who's watching this as a recording on YouTube, feel free to post a comment there as well. We do read the comments. We come back to the videos, so you can always ask us afterwards. All right. I think we've given some time. Anais, are you cool with calling it?
I'm good with calling it. Thanks, everyone.
Right. Bye, everyone.
Bye.